We're talking about a massive solar storm here. They are calling it a severe geomagnetic storm. It threatens to have an impact on our power grids, our communications, and just maybe give us a look at something that is very rarely ever seen here in the Southland. Watch.
NASA just announced that the sun is about emitting extremely large bursts of energy that are directly heading for Earth. If these bursts reach us, they have the potential to cause significant damage to humanity's livelihood. Power grids could be completely disabled, and our communication systems could cease to function. This could effectively regress humanity to a primitive state, reminiscent of the Stone Age. But what makes these bursts so dangerous? Why is this event happening now in the year 2024? And why are they considered highly perilous? Welcome to Astro Quest, where we explore the consequences of the solar storm about striking Earth this 2024. So how would such an event actually unfold? It all begins with the sun's natural cycle, known as the solar cycle, which spans over 11 years. During this cycle, the sun's solar activity experiences periods of increase and decrease. The cycle commences with a few active sunspots generating substantial amounts of energy. Then, around 5 or 6 years later, it reaches its peak, when the number of sunspots escalates to anywhere between 100 and 200. After that, solar activity gradually diminishes over the remaining 5 years, leading to the beginning of a new solar cycle. Presently, we find ourselves in the 25th cycle of solar activity since the commencement of sun tracking in 1755. Unfortunately, scientists predict that the sunspot numbers will peak in 2024, heightening the likelihood of a solar storm occurrence. Now, before delving into the solar storm, let's understand what sunspots actually are. They are regions on the sun's surface that appear cooler and darker due to their strong magnetic fields. While sunspots themselves do not directly trigger solar flares, it is noteworthy that flares tend to be more prevalent in these areas owing to their heightened magnetic activity. The magnetic field lines near specific portions of the sun can become twisted and entangled, leading to sudden snapping and realignment, resulting in a release of an immense amount of energy, a phenomenon known as a solar storm. So once the sun discharges this substantial energy, what will happen on Earth? Initially, the effects of a solar storm may not be immediately noticeable, as it takes a few minutes for the storm to reach our planet. One of the initial noticeable changes will be the increasing occurrence of auroras worldwide. This phenomenon arises when charged particles from the solar storm interact with the Earth's atmosphere. While these celestial displays are visually stunning, the positive aspects of a solar flare end there. The impact on our geomagnetic field would cause a widespread disruption in our technology. Satellites, GPS systems, and radio transmissions would experience significant interruptions. Your cell phone would likely struggle to receive any signal, leading to a decline in global communications reliability. However, it's important to note that these disruptions would only be the result of a few solar flares. In the case of an entire solar storm, we're dealing with multiple assaults by the sun on Earth. But it's not just the people on Earth who would be affected by this phenomenon. Astronauts in space would indeed face severe consequences, potentially worse than those on Earth. They would be subjected to intense solar radiation from the sun, and unless they are within a specially shielded area of the spacecraft, a solar storm could pose a deadly threat to them. Exposure to such high levels of radiation could result in radiation sickness, and the long-term risk of developing cancer would also be a concern. Furthermore, the solar storm could disrupt their ability to communicate effectively with mission control, creating significant challenges and potential dangers. This description covers the initial impacts on the first day of the solar storm. However, several days later, as terrestrial communication difficulties persist, another formidable assault would occur. This event is known as a coronal mass ejection, CME, and it would be directly heading towards Earth. A coronal mass ejection, CME, refers to a colossal release of plasma and electromagnetic radiation from the Sun. This ejection possesses the potential to trigger severe geomagnetic storms, which can disrupt Earth's magnetic field. Should such an event occur, it could result in permanent changes to our planet. An illustrative example is the Carrington Event of 1859, a notable solar storm that had a profound impact. It caused significant disruptions and even destruction of telegraph communications at the time. Fortunately, given the simplicity of the telegraph system, recovery was relatively swift, considering the circumstances. Telegraph lines could be repaired quickly and life returned to normal. However, the situation would be vastly different in today's world. Our lives are heavily reliant on advanced technology, and its prevalence is far more extensive. In the event of a solar storm, the disruptions wouldn't be limited to occasional glitches or temporary signal loss. Instead, it could be so severe that all technology ceases to function. The intense electromagnetic radiation could potentially render entire power grids and communication systems inoperable. The consequences would be far-reaching and impactful. Something as simple as making a credit card purchase for groceries would become unattainable in the scenario being discussed, an extensive global power outage. The consequences would be far-reaching, as even aircraft could lose contact with air traffic control, leading to a loss of navigational guidance. Consequently, planes could potentially crash due to the heightened radiation levels affecting Earth. The same risks apply to subways and trains, which could abruptly halt, causing widespread disasters worldwide. In such a scenario, the absence of electricity in homes would be the least concerning issue globally. Complete cities, including essential facilities like hospitals, would be deprived of power, making it significantly challenging, if not impossible, to provide adequate medical treatment to certain patients. The absence of power and technological malfunctions could result in the loss of millions of lives. Although solar flares and coronal mass ejections, CMEs, might endure for several hours or even days, the consequences of this event would persist beyond that time frame. Given the extensive damage inflicted upon power grids, communication networks, and technology, Earth's recovery would require a considerable amount of time. It could take weeks or even months to restore normalcy, necessitating the reconstruction of various components of power grids and communication systems. The duration of the recovery process would depend on the availability of necessary components, potentially extending the timeline by several additional weeks. Furthermore, the lack of communication on a global scale would pose significant challenges. While communicating with neighbors might still be feasible, establishing contact with distant cities or countries would be highly problematic. The collapse of global supply chains would further exacerbate the delays in rebuilding efforts. However, once humanity manages to address these issues, the process of reconstruction would commence. What initially seemed like the end of humanity could eventually become a mere footnote in Earth's history. The likelihood of a solar storm of this magnitude is difficult to determine with certainty. By studying solar cycles and tracking the occurrence of solar flares, we can gain some insights. However, whether or not these flares will directly impact Earth remains unpredictable. It is important to note that although our reliance on technology has increased significantly, the resilience of our technological systems has also improved. Communication technology and power grids are designed to withstand various forms of interference, providing a certain level of protection against such events. NASA is indeed actively involved in developing technologies to enhance solar flare prediction and warning systems. In the event of an approaching solar flare, there are several steps you can take to prepare. Furthermore, considering alternative power sources such as off-grid power supplies, generators, or solar panels is a prudent measure. By having backup energy options, you can mitigate the impact of power outages caused by solar events. Patience is key during such situations, as it is expected that the world will eventually return to normalcy after the event subsides. However, contemplating extreme doomsday scenarios where Earth faces unprecedented and catastrophic events raises an intriguing question. What if our planet were to encounter some of the most unimaginable world-ending situations? Subscribe to our channel for more updates on this mind-blowing cosmos event.